Okay, Rich. This theorem 10.11 actually, this one, you basically just think about what it says and be able to apply it. That's really that's what I would say. I think it's pretty straightforward, really. It basically says you have a circle, you have a chord AB. I marked it, chord AB. So because of that chord, you have arc AB that I've marked in red, and you have the remaining part of the arc, the remaining part of the circumference, which is also a bigger arc, BCA, going the other way. Okay, and then you have a tangent. So this theorem involves a situation where you have a chord and a tangent. Now notice that this is not 90 degrees. This chord is not perpendicular to the tangent. It will only be perpendicular if the chord were a diameter. Remember, a tangent is only 90 degrees to a radius to that point. So don't be confused that, this is just any old chord. It could be like that, it could be like that, it could be like that. It's just a chord. It's not a radius, so it doesn't have to be at 90 degrees to the tangent. Anyway, so this theorem says if you have a chord and you have a tangent at a point A, then it says if a tangent and a chord intersect at a point on a circle, so a tangent and a chord intersecting at point A, then the measure of each angle formed, of course there are two angles formed, right? Angle 1, right, because there's a tangent and there's a chord, so there's this angle, and then there is the angle going the other way. Okay, of course they are in fact what? Supplementary. Of course 1 and 2 angles, measure of angle 1 and measure of angle 2 are supplementary, but that's not what this theorem is talking about. I just made that observation. This theorem says then the measure of each angle is 1/2 the measure of its intercepted arc. So for example, it's saying this angle, its intercepted arc is that one, right? And then this angle, its intercepted arc is that other one, right? So it's saying measure of angle 1 is equal to half the measure of arc AB. Remember now, the measure of arc AB is what? You come back to the center. It's a central angle to find measure of arc AB, and also to find measure of arc BCA is also the central measure. But of course, if you know the measure of arc AB, then you just subtract that from 360 degrees to find the measure of arc BCA, because that's the remaining of the circle. And we know that everything at the center is 360, so if we know what's central angle associated with AB, then we know the remainder associated with BCA will be 360 minus the one associated with AB. Anyway, so just try to remember this figure, how it's drawn. So it involves a chord, it involves a tangent, and there are two angles in that place. And this is just a theorem to help you figure what those angles are. Okay?